angle A to start with alternate angles. Alternate or opposite angles. Alternate or opposite angles. Alternate, opposite. Now, the position of A. A is where? Top and left. You agree? Top and left. Now, let's look of something that is down and right. Down, right. Down, right. D is down, right. Do you see? D is down, right. Down, right. Can you see? It is down here, down on this line, and right on that line. Therefore, A is alternate. A is what? Alternate to to D. A is alternate to D. Down, right. Different positions. Let's look for another one. H. H is also down, right. H is down, right. Do you see it? H is down, right. H. Angle H. Down, right. Therefore, it's alternative to what? Angle A. So you look at different positions, and that is your choice. So simple. But one strange thing, one interesting thing about alternate angles is that though they are alternate angles, they are opposite, they are enemies, but they are equal in principle. Let's see why. Look at angle A. Have you seen angle A? Good. Have you seen the size of it? Let's look at angle H as another example. If we turn it and let it sit on this, it will be equal. Apart from that, they have the property of vertically opposite angle. Do you remember? We said this angle is equal to that angle, isn't it? Yes. Watch. A and D, we realize that A is alternate to D. And you can see that it's the same principle. This is A and this is D, vertical opposite. So it's behaving like vertical opposite, but the name is not vertical opposite. Why? We can get it here. So A and D are vertical opposite and at the same time alternate. Vertical opposite at the same time alternate. But A and H are alternate only, not vertical opposite. Vertical opposite happens at a point, just like scissors, right? So that's the principle. But alternate angles, you pick one here and pick one at another point. That is how it occurs. But they are equal in principle and in size. So let's see, consider that. So these are the properties. Now, apart from that, you can get co-interior angles here. Co-interior, when it says you are a co to somebody, co-workers. Who are co-workers? Yes, co. So this is co to that. Vertical opposite, right? This is opposite to that. Can you see? Co-interior. You are co-workers. You sit on one table. This is the desk you are using to work. This is the desk. One sit here, one sit opposite to him. You are co-workers, colleagues, right? This also same, this and that. So when you come here, C and E sit on this straight line. Do you see? This is a straight line. C and E sit on it. And if they sit on a straight line, then the principle is that C plus E must be equal to what? I'm asking you. Yes, 180 degrees. It has the property of straight line angles. So co-interior angles sum up to 180 degrees. So give me another co-interior. F and what? F and D. They sit on this straight line. F and D. Right? So I can get co-interior here and there. This and that sum up to 180. This and that sum up to 180. This and that. This and that sum up to 180. This and that sum up to 180. But when I come here, B does not have a partner, right? Opposite direct to it. They don't sit on the same office or desk. So you can see that this one cannot be co-interior to any other angle. So take note of that. That's another property you can find. But remember that vertical opposite is playing a role here, is showing here. So you can apply vertical opposite. Straight line is also showing here. A plus B equals 180. Do you agree? Because this is a straight line and it's divided into 2. A plus B equals 180. C plus D 180. A plus C here. AC 180. B D 180. Do you see it? Yes. E F plus E plus F 180. Because they sit on this straight line. And so they meant to see a straight line and it's divided. No matter the number of times divided. Right? If I can identify that from here to here is a straight line. This is given, and they ask for this. It's x plus this equal to 180. Then I get the x. I can also picture this straight line. Can you see? Watch me. This is a straight line, and it's made up of this angle, the one I'm shading, yes, this angle plus this one plus that one, using this straight line. So the minute you can identify a straight line, you can apply. So vertical opposite angles are very popular in circuit theorem and all the works you're going to do in angles, right? Apply it. Straight line is also popular. Apply it. You talk about corresponding and alternate angles if and only if it's talking about parallel lines. That is the only way you apply them. Parallel lines. So you think of them when you get parallel line question. I hope it is clear over here. Very, very important. The rest, straight line, vertical opposite, you can apply them. Circle is also operating here. Can you see? A plus B plus C all together. So if you have 3 of them, I need 1. 1, 2, 3, 4 equal to circle. So that's also possible. So E plus F plus G plus H also circle. Take note of that. So circle is operating here. Straight line is operating here. Vertical opposite is also operating here. They are very common. They are very, very, very common. So try to apply them. Right. So these are the special angles we are talking about. Now let's move to the next type of angle. The next type of angle. Let's move to the next type of angle. Now, apart from angle properties of parallel lines, we can also get angle properties of triangles. Right? Angle properties of triangles. Right? So let me start from here. Angle properties of triangles. Good. You can see this triangle. I'm sure it's beautiful. It's a beautiful triangle, right? Good. Can you see the triangle? The sum of interior angles of a triangle is equal to what? 180. You know it. It's basic. Class 3 or even 2. The sum of all the 3 interior angles. So A plus B, then I've written it here. A plus B plus C equal to 180 degrees. It's very common. That's one. Can you see straight line operating here? C plus E. This is a straight line and divided into this. So C plus E equals 180. Right? D plus A 180 because this is a straight line. B plus F, this is a straight line equal to 180. So the straight line is applying here. Take note. That's why I said it's very popular and very common. Now, let's go. Apart from the property of the sum of the 3 interior equal to 180, the sum of 2 opposite interior, right? The sum of 2 interior angles of a triangle is equal to the external to that angle, those 2 angles. What do I mean? If we sum A and B, the opposite exterior angle is E. That's all. So A plus B is equal to E. Yes. If I sum A and C, A plus C, only 2, not all the 3, only 2, A plus C must be equal to the external opposite to it. The external is what? F. So equal to what? F, as indicated here. Do you see that property? Very beautiful property. Therefore, let me ask you, and I leave that one for you to answer. B plus C should be equal to what? Right? B plus C should be equal to what angle? That is an assignment for you to tackle. So, thanks for that. So, these are the properties you can apply here. And it's very popular, the external property. You mean to see a triangle extended and you see an angle outside and you see another angle there. Look for the opposite one, the one, and I sum them equate to that. Or when you get this one, you can apply the property of straight line. When you get this plus this equal to what? 180. So it's the same straight line, vertical opposite repeating itself. And vertical opposite is operating here. When you extend this line, right? Extend that line. C equals here. E equals here. Isn't it? So simple as ABC. Right? So let's move to the other property.